Just a few minutes. Good morning, dear students. Sorry for the little late. First of all, I would like to explain if you have any doubts, because whatever the topic today we are going to discuss is the next week, and of course moreover it is not even coming into the cumulative examination also. So we should give the priority to the today's syllabus, today's exam, okay, and the cumulative. So first of all, let us clear the doubts. So please tell me whatever the doubts you have. Quickly, please. Are you doing the work properly? Okay. So, right, resonance. 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 Right. The phenomena of the phenomenon of writing, the phenomena of writing of two or more, Lewis structures, possible Lewis structures, okay, and none of them singly explains all the properties of the molecule. The phenomena of writing of two or more possible Lewis structures, and none of them singly explains all the properties of the molecule, okay, is called that phenomena is called resonance. For example, carbonate ion is there, CO3 minus 2. You can write okay, minus 1. So CO3 minus 2, this is one structure you can write. So this is one oxygen atom, next oxygen atom, next 3 oxygen atoms. I'm just giving the numbering. This is oxygen 1, oxygen 2, oxygen 3. First oxygen gets double bond, remaining 2 oxygens get single bonds in the Lewis dot structure of CO3. Now, resonance structures can be separated. Okay, can be represented with this kind of arrow mark. So, next time I would like to write the double bond at the second oxygen, and this first oxygen I would like to take it only single bond oxygen with negative charge minus, and this one is as usual. This is first oxygen, second oxygen, third oxygen. So now I am writing the double bond with this second oxygen. Next to this one is single bond, this one is also single bond, and this one is the double bond. Like this. Okay, now. So totally I have written how many? First time double bond at the first oxygen, second time double bond is at the second oxygen, third time double bond is at the third oxygen. So I was able to write totally 3 structures. 3 structures. So now this structure, none of them individually explain all the properties. 100% this one is not correct. 100% this one is not correct. 100% this one is also not correct. Means none of them singly, individually can explain all the properties of the molecule. So these are all called what? Contributory structures, also called as resonance structures, also called as canonical structures. Okay, these structures. So I was able to write totally 3 structures. So more than one structure if you are able to write, which means that molecule is exhibit the phenomena of resonance. Okay, if you are able to write 2 or more structures, then the molecule is said to be exhibit what phenomena? Resonance. So none of them individually, only consider this structure is wrong. Only consider this structure also wrong. Okay, so these are called what? Resonance structures. Resonance structures or canonical structures. Canonical structures or contributory structures. Contributory structures. Resonance structures or canonical structures or contributory structures. So what does it mean? Actual CO3 minus 2 is there. So this whatever the structure I have written, so partly this structure is correct. This one also partly, this one is correct, that one also. So if you take some amount of characteristics of this, characteristics of that, characteristics of that, all together if you mix, then that is what? Hybrid, resonance hybrid. We can call it as what? Resonance hybrid will be obtained. So characteristics of this one you consider, characteristics of this one and that one. So all the characteristics if you mix and you take a structure, then that is what? Resonance hybrid. Resonance hybrid, that is the actual structure of the compound. Okay, so that phenomena is called what? Resonance hybrid. Resonance concept. So have you written the statement first?
सर सर आइसोमर्स के रेजोनेंस के ये डिफरेंस सर.
Isomers are the different compounds of say having same molecular formula, different compounds. Resonance is the one compound only. For that, we are able to write different structures. One compound, say
సార్ ఐసోమర్స్
carbonate.
కూడా డిఫరెంట్ స్ట్రక్చర్స్ కదా సార్, ఎన్ అండి అదొక స్ట్రక్చర్, అలాగే వేరే వేరే
This
ఉంటాయి.
is the atom's position. The atom's nuclei position connectivity does not changes. Only electronic positions we have changed. So double bond here, there, so lone pair. We are not moving the atoms. We are not moving. We are not changing the atoms. In isomerism, atoms positions is going to be changed. So connectivity difference, spatial alignment difference will come. So this is what carbonate, one structure. This is not actually the true structure of carbonate. Somehow it is contribute to the true structure. So we are all writing the possible electronic structure of the carbonate. So the resonance is a different concept. Isomerism is a different concept. Isomerism is okay, molecular formula only same. Then there will be a difference in the structure. Structure means connectivity. Atom will be connected to another atom, particular atom. In the other case, it may be connected to other one. So isomerism is completely different from the resonance. So just wait for a few minutes. Okay, I have not completed the resonance concept. Okay, so once you get the conclusion about this resonance, then you can understand the difference between resonance and isomerism. Just I have given the statement and just discussing of one example initiated, not yet done.
ఓకే సార్, థ్యాంక్ యూ సార్.
So this one somehow some percent will be contributed to the original structure. This one also, this one also. Okay, so I'm writing the continuation for this. So continuation. See, okay, exact structures రాయక్కర్లేదు ఎందుకంటే structure, exact structure, spatial alignment is not mentioned by the Lewis theory, so no need to write like that. Now you see, in every case, there is at least one complete single bond, complete single bond. Here also single bond there. Okay, so this is what observed. At least one single bond between these atoms is observed. So the resonance hybrid contains at least one single bond. Sometimes your double bond is appearing at here. Sometimes double bond is appearing at here. Sometimes double bond is appearing here. You may not take completely double bond at here because you can also write double bond there. You can also write double bond here. So you need to distribute the double bond character. You need to distribute the double bond character all these three positions. So what you need to do? Partially. Sometimes double bond you can consider. Here also partially. It's not purely double bond, but not single bond. It is not purely double bond, but not a single bond also. What it is? More than single bond, less than a double bond. So there is a partial double bond character. Because double bond can be present at here or there, only one double bond. But you can write between any three. So you can distribute equally the double bond character. Double bond character you can distribute. So the double bond purely not staying at one particular two particular atoms only. Double bond don't be present at between these two. Sometimes double bond 33.3% can be stay at here. 33.3% time can be presented here. This one. So the double bond character will be distributed equally wherever we are able to write. So here we are able to write, there also and there also. So at all these three positions you can distribute the double bond character. So now the negative charge, the minus one charge can be given, and also this given to this two, and this one also given to this two. So negative charge also equally distributing to all the oxidants, not two particular atoms. not to particular oxygen atoms. So negative charge also can be distributed equally. So therefore, this is what overall you can write -2. Don't give the -1 sign directly to anyone. This is called what? Resonance hybrid. Resonance hybrid. Hybrid means you take the characteristics of this one, characteristics of this one, and characteristics of this one, all you consider, and together if you represent, then this is the molecule obtained, structure is obtained. So this is what we can call it as resonance hybrid structure. Okay. So resonance hybrid structure, this and these are called resonance structures. Okay, also called as contributor structures or canonical structures. Right? How much percent of this contributed means, for example, in the 3 resonance structure, this is resonance structure 1, resonance structure 2, resonance structure 3. Okay, among all the resonance structures, okay, all of them are equally stable. So we have to say which resonance structure is stable. Okay, whoever the resonance structure among all the structures written who is more stable, that characteristic, okay, will be represented in the hybrid structure more. The less stable structure contribution characteristics in the hybrid structure will be less. So in a general way, how to explain this? Okay, there are 3 persons. Okay, 3 persons celebrating a function. Then the person A, B, C, the person who is more active or who is more involved in the process, then that person impact, that person characteristics will be appear more in the output. So the person who is contributing less, okay, simply for example, 3 persons are organizing something, they are contributing the money. So the one contribute more money to the function or any the process, then he will have more command, he will have, his impact will be more on it. Similarly, you can able to write 2 or more structures. In those structures, some of these structures will be less stable structures. Some of the structures are more stable structures. Then the more stable structure can contribute more to the resonance hybrid. That means contribute more means that stable structure characteristics, whatever the characteristics that possessed by the stable resonance structure, that characteristics will be appear more in the original structure. So that's why we can call them as contributory structures. So here the resonance structures have written 3 structures for the carbonate ion. All the 3 structures are equally stable. Identical resonance structures are equivalent resonance structures. So here contribution from this, contribution from this, contribution from this, all are equal. Okay. So write these structures and write the resonance hybrid. I will give some conditions to exhibit resonance structures. Okay. So first of all, complete the writing part. This. Identical resonance structures also called as canonical structures. conditions. Conditions to have resonance, to write resonance structures, to write resonance structures. Structures. Conditions to write the resonance structures. Atoms, connectivity, positions should not be changed. Should not be changed. Should not be changed. Okay, in every resonance structure, once you are writing one atom or one particular connectivity is written, you have to write in all the resonance structures with same connectivity only. Connectivity should not be changed. The position of atom should not be changed. So atom's connectivity, the position should not be changed. Next, total number of valence electrons. Total number of valence electrons should be same. Should be same.
Sir.
In all RS.
Sir. సార్ ఈ రెసిడెన్స్ స్ట్రక్చర్ స్ట్రాంగ్ ఉంటుందా లేకపోతే రెసిడెన్స్ హైబ్రిడ్ స్ట్రాంగ్ ఉంటుందా?
Resonance structures are imaginary structures. Resonance structures are imaginary. We are writing. Lewis defined structures. Strong untaya, weak untaya kaadu. They are just imaginary structures. They are not real existing. Okay. So if you are writing the structures and from that characteristic you extract and you write a resultant of all the three, then we can get a hybrid structure. So the hybrid structure is the original structure. These are all imaginary structures.
సరే అంటే ఉండవా నార్మల్ మనం థింక్ చేసుకుని
రాసుకున్నవి.
సార్ మీరు నార్మల్ గా డాటెడ్ గా బాండ్ గీసారు కదా సార్ రెసిడెన్స్ హైబ్రిడ్ లోనా, దాన్ని ఏ బాండ్ అంటాం సార్?
బాండే, కాకపోతే పార్షియల్ బాండ్ అంటాం. అంటే కంప్లీట్ గా ఇప్పుడు ఇలా రాశాను అనుకో
సార్ వాండర్వల్ ఫోర్సెస్ కింద వస్తుందా?
వాండర్వల్ ఫోర్సెస్ వదిలేసాను నన్ను. వాండర్వల్ ఫోర్సెస్ కాన్సెప్ట్ అయిపోయింది. ఇట్స్ అ బాండ్, నార్మల్ కోవలెంట్ బాండ్ ఓన్లీ, డబుల్ బాండ్ ఓన్లీ, double bond only, but not completely double bond. Purely double bond not staying at here. Double bond sometimes can present at here. Okay, within a second, one third second, the double bond present at here. Double bond, that double bond character is distributed to all. So it is not complete bond. So dot means it's a partial bond. Partial bond, not complete bond.
Okay.
Total number of valence electrons should be same in all RS. RS means resonance structures. In all resonance structures, total number of valence electrons in all resonance structures should be same. Okay. Now, characteristics of the Characteristics of resonance. Characteristics of resonance. Characteristics of resonance. Resonance gives stability. Resonance gives stability to the molecule. Resonance gives stability to the molecule. More is the stability, more is the resonance. The more is the resonance, the more is the resonance, means more number of resonance structures are possible. More number of resonance structures are possible. Okay, the more is the resonance. More resonance means what? That is more number of resonance structures are possible. Then the more is the stability. The more is the resonance, the more is the stability. The more is the resonance, the more is the stability. Next. Identical or equivalent resonance structures. Identical or equivalent resonance structures can give even more stability. Identical or equivalent resonance structures can give even more stability. Characteristics of resonance. Next. Resonance may result same bond lengths. I will explain this point later. Resonance may result same bond length. Resonance structures have no real existence. No real existence. That's why I told you, it's an imaginary structures. So we are writing the structures. Okay, so no real existence. Actual structure is, that is what hybrid structure. For that, we are able to write Lewis structures. Okay, so these structures are just we are writing. They are not real structures, so have no real existence. So resonance structures are not separable. Are not separable. Of course, there is no real existence. Means how can we separate the this structure, that structure? Not separable.
సార్ సార్ ఐడెంటికల్ అండ్ ఈక్వలెంట్ రెసొనెన్స్ అంటే ఏంటి సార్?
చెప్తాను. Just a minute. Wait. I will tell you difference between identical or equivalent resonance structures, so non-equivalent resonance structures. So now, last point, that the relative stability of resonance structures can be identified can be determined using formal charges, concept. The most stable structure, that is lowest energy. Lesser the energy, more is the stability. Lowest energy, the most stable structure or the lowest energy structure is the one in which has smallest formal charges, which has the smallest formal charges, small formal charges, or zero formal charges, smallest formal charges or zero formal charges on the atoms. So which is most stable resonance structure? The one which has Smallest formal charges or zero formal charges on the atoms in the structures are called what? Most stable. So now we need to learn what is meant by formal charge. Okay. So assign the formal charges based on the formal charges among the all resonance structures. Which resonance structure is more stable? Okay, more stable. Then that structure will contribute more to the resonance structures. So please write down. I will tell you what is meant by what is the difference between equivalent resonance structures, identical resonance structures, and different resonance structures. And then I will explain the formal charge. Okay. So please write quickly. So which is more stable? The smallest formal charges. What is the one point? Second point is negative formal charge on more electronegative atom. Negative formal charge on more electronegative atom. Positive formal charge on less electronegative atom. For lowest, the smallest formal charges, and the negative charge is on more electronegative atom. Okay, positive charge is on less electronegative atom. Will give most stable resonance structures. So please write everyone. Don't leave it. Everyone have to write this. Just wait for a few minutes. So you will get a conclusion for this. right? So now look at the structures. Hmm. Let us take N2O, N2O, nitrogen, oxygen. Okay. So Lewis dot structures: a triple bond, single bond, lone pair. Okay, like this is the one structure you can write for N2O. Correct or not? Let us check. 5 2s are 10, 10 plus 6, 16 electrons. Total valence electron 16. 1, 2, 3, 4, 5, 6, 7, 8. 8 2s are 16 electrons. So total valence electron 16. This is the one way of writing Lewis dot structure. This is one structure. So next way you can write is, you can write a double bond N, double bond O. Okay, lone pair. Okay, so this one contains two lone pairs, like 1, 2, 3, 4, 5, 6, 7, 8. 8 2s are 16. So this is the way, one way of writing Lewis dot structure. Okay. Yes, third one.
Sir,
Third one now.
sir, మీ వీడియో స్టాప్ అయిపోయింది.
Stop it. So ఎప్పుడు స్టాప్ అయింది?
ఇప్పుడే సార్.
Just okay. So I'm writing third Lewis dot structure. Okay, now the third Lewis structure is single bond and triple bond O, lone pair, and this one contains. So you can write the Lewis dot structure for N2O in three ways. Now look at all the three structures. Is there any similarities between the structures? Totally we are writing three structures. So these three are resonance structures. These three are what? Resonance structures. Resonance structure. That means you are able to write total three ways using the 16 electrons. And this is the skeleton structure. Don't change the skeleton structure. Don't change the skeleton structure. Atom's position should not be changed. Only electronic arrangement, somewhere single bond, triple bond, double bond, 11 pairs like this you can write. So totally you are able to write three ways you can write. Using the rules, we can write three ways. So totally three structures we are obtaining. These three structures are what? Resonance structures, but not identical, but not identical. But not identical. Are they identical? Triple bond, single bond, double bond. Is there identical? Is there? No. But not identical or equivalent. Equivalent. Whereas just now only I have written the resonance structures for the carbonator, CO3 minus 2. For that I have written the resonance structures like this. I'm not writing the dots. C double bond O, single bond O minus, single bond O minus. C double bond O, single bond O minus, single bond O minus. C double bond O, single bond O minus, single bond O minus. So what you can say, this kind of structures are what? Identical resonance structures or equivalent resonance structures. C double bond O, single bond O minus, single bond O minus. C double bond O, single bond O minus, single bond O minus. Benzene is there. This is what we can call it as benzene structure. Okay, so Another structure for the benzene is this. So these two are what? Identical resonance structures or equivalent resonance structures. Next one you see, CH3, C double bond O, O minus, CH3, C O minus, double bond O. So this double bond, double C double bond O, O minus, single bond O minus, C double bond O, single bond O minus. So these two also we can call them as what? Identical or equivalent resonance structures. These are also equivalent resonance structures, but these are not equivalent resonance structures. So I hope you understand what is meant by equivalent resonance structures and normal resonance structures. Equivalent resonance structures also called as canonical structures, but in general, resonance structures also can be named as canonical structures. Okay. So I will come back to this one is again. Now, so the which resonance structure is more stable? Which resonance structure is more stable can be identified by using formal charge. Now put a heading formal charge. Formal charge. The formal charge is the difference in the number of electrons assigned. So number of valence electrons. Number of valence electrons. Someone is unmuted, so please mute yourself. The number of valence electrons of an atom. Number of valence electrons of an atom in free state. Free state. That means not in combined state. Only single atom freely it is present. So whatever the valence electrons are there, that is the free state. So number of valence electrons of an atom in free state minus number of electrons assigned to that atom in a Lewis structure of a molecule. Lewis structure of a molecule. Lewis structure of a molecule. So what is this difference? So formal charge. Sometimes F or QF. Formal charge. The formal charge of an atom can be defined as difference. What is formal charge? Is the difference of what? The number of valence electrons of an atom in the free state and the number of electrons assigned to that atom in a Lewis structure of a molecule. So there is a formula for calculation of formal charge. Okay, that is Na minus N lone pairs minus half of the N bond pairs. This is the formula. How to calculate the formal charge? Na minus NLP minus half of the N bond pairs. What is Na? Na is the number of valence electrons in free state. Number of valence electrons in free state of an atom. NLP. Okay, number of electrons as lone pairs. Okay, N bond pairs. Yes, same number of electrons as bond pairs. Bond pairs. So write this, I will explain now. Completed? This is the formula for calculation of formal charges of atoms. So for example, now you will be getting some conclusion there. Okay, listen carefully. For example, N2O, N2O you take, total valence electrons.
Hello,
Total
sir.
valence electrons 16.
Sir, your video is turned off.
Sir, video అయిపోయింది సార్.
So can I rub this part? So now you see total N2O, total number of valence electrons 16. So first resonance structure I can write for the nitro. This one is N single bond O. You know how to write the Lewis dot structures. The first structure I'm going to write is this. Okay. This is the first Lewis structure I'm going to write 1, 2, 3, 4, 5, 6, 7, 8, 8 to the 16. This nitrogen I will number as 1. This nitrogen I will number as 2, just for distinguishing of these two nitrogens, okay? And oxygen, only one oxygen is there, so no problem. Okay, so the formal charge of N1, first nitrogen, formal charge of first nitrogen 1, or this nitrogen is equal to what? So apply the formula. Simple, the formula is, we are finding the formal charge for nitrogen. Okay, nitrogen belongs to 50 group. When nitrogen present separately, individually, Okay, free state. Nitrogen valence electrons 5. Nitrogen atom valence electrons so many? 5. So that is the first one. The number of electrons present in the valence electrons in the free state. When nitrogen atom is not bonding with any others, freely present, it will contain 5 valence electrons. That is what we have to write 5. Minus number of electrons present as lone pairs. Number of electrons as pairs. Now we don't take it as a pair. You have to take electrons as present as a lone pairs. So how many electrons as present as lone pair? There is only one pair. Means 2 electrons. 2 electrons. Don't take one. They are not taking the pairs. They are taking the electrons as lone pairs, as non-bonding electrons. So 2 electrons are there. Okay, which is as appearing as a lone pair. So 2 minus half into. Okay, how many bond pair of electrons? 1, 2, 3. 3 twos are 6. 3 twos are 6. One bond is represent how much? 2 electrons. Ante half ante em ledandi. This is what? Because 6 electrons, 3 belongs to nitrogen, 3 belongs to nitrogen. So how many electrons belongs to this nitrogen? How many electrons belongs to this nitrogen? Means 3. So for that purpose only half taken. Half into number of bond pairs. Okay, half into number of electrons as bond pairs. Number of electrons as bond pairs. 6 electrons are there as bond pair for this nitrogen. So in that half, how much you will get? 5 minus 2, 3 minus 3. 3 minus 3, 0. So the formal charge of the first nitrogen, the charge actually you can imagine, okay, is what? 0 for this. Now the formal charge of second nitrogen. Formal charge of the second nitrogen, how to calculate? Yes, when nitrogen atom is present in the free state, the number of valence electrons 5 minus number of electrons present as a lone pairs. In this Lewis structure, no lone pairs present on the nitrogen. So therefore, number of electrons present as a lone pairs. Number of electrons present as a lone pairs 0. No. Minus half into. This nitrogen contains totally 4 bond pairs. 1, 2, 3, 4. Totally how many? 4 are there. 4 twos are 8. So 8 electrons present as bond pairs. Okay. So you will get now 5. This is minus 4. 5 minus 4 you will get 1. That is nothing but plus 1. How much? Plus 1. So the second nitrogen formal charge plus 1. First nitrogen formal charge 0. Next, the formal charge of oxygen you take. Formal charge of oxygen you take, that is equal to. Formal charge of oxygen you take, that is equal to how much? Oxygen when it is present in the free state. Oxygen when it is present in the free state. The valence electrons 6. 60A group valence electron 6. Minus number of electrons present as a bond lone pairs. Number of electrons as bond pairs. Sorry. Number of electrons as lone pairs. 1, 2, 3, 4, 5, 6. So 3 twos are 6. 6 electrons are there. 3 pairs 6 electrons. So number of electrons as lone pairs 6 minus half into number of electrons as bond pairs. This is only bond pair. So into 2 electrons. One bond means you can take 2 electrons. 1 bond 2 electrons. 3 bonds 6 electrons. 4 bonds 8 electrons, like that. Okay. So 6 minus 6 minus 1. That is equal to total charge is how much? Minus 1. Okay. First nitrogen formal charge 0. Second nitrogen formal charge plus 1. Oxygen formal charge is minus 1. So we can also write that Lewis structure as overall net charge 0, because plus 1 no minus 1, plus 1 minus 1, plus 1 minus 1, total net charge 0. This is what we can call them as formal charges. But N2 is neutral molecule. Neutral molecule. Individually, the charges that possess nitrogen 0, no need to write. So +1, -1. So these are called what? Formal charges. Okay. So write the formal charges of that first resonance structure. So I will write another resonance structures, 2 more resonance structures. For them also I will write the formal charges.
Sir,
So among the all which has the least formal charges according to the rules, we can identify which is more stable resonance structure.
sir,
Ah,
సార్ అంటే మనము ఇలా మొత్తం రాసినప్పుడు లోన్ పేర్స్ రాయకూడదా ఫార్ములా చార్జ్ రాసినప్పుడు మళ్ళీ
right.
ఆ?
Lone pairs also you can represent. You can represent lone pairs also.
ఓకే
No problem. Whether you write
Okay.
or not, no problem.
ఓకే సార్
-1, +1. Plus circle means +1, minus circle means -1. Done. Right. Second Lewis structure I will write now. Okay. N double bond N double bond O like this. Okay, now this is the first one I have written. Right. So again I will number it 1, 2 and oxygen. So find the formal charge of N, first nitrogen formal charge. How much? When it is present in the free state, 5 minus number of electrons as a lone pair, 1, 2, 3, 4, 4 electrons minus half into number of electrons present as a bond pair. Okay, so 2 pairs, 2 bonds means 4 electrons. 2 bonds means 4 electrons. It's just simple. Actually, it is when it is not present in the bonding, it will contain 5 electrons. Okay, now in this Lewis structure, how many electrons are assigned? Lone pairs means completely belongs to nitrogen. So 1, 2, 3, 4. So 2 bond pairs means 2 electrons are assigned to nitrogen. Another 2 electrons assigned to nitrogen. They are contributing like that. We are showing. So total number of electrons 1, 2, 3, 4, 5, 6 electrons. It is present actually in the free state. It is 5 electrons, but in this structure we have assigned 6 electrons we are assigned. How many electrons are assigned? 6 electrons are assigned to this nitrogen. Okay, actually it contains in free state 5 electrons. So extra 1 electron is assigned to it. Extra 1 electron is assigned to it. Extra electron means -1. So this nitrogen will get -1 charge. You see how much it is? -1. No? This is how much? -2, -4, -6 plus 5. -6 plus 5, -1. So now nitrogen carries -1 charge. Nitrogen carry, first nitrogen carry how much? -1 charge. Second Lewis structure if you take, okay, N double bond N, okay, so contains 2 lone pairs and a negative charge. Now formal charge of second nitrogen if you take, in free state 5 electrons, number of electrons as a lone pair assigned to it. No lone pairs are assigned to it. So number of electrons, lone pairs as a 0 for this, minus half into, okay, 1, 2, 3, 4, 4 twos are 8 electrons. So total bond pairs 8. So half of that 8. So you will get how much? 5 minus 4. So plus 1. So the middle nitrogen, second nitrogen carry how much? +1 charge. Okay, formal charge of the oxygen atom is equal to, when oxygen atom present in free state, the valence electron 6, okay, minus number of electrons as a lone pairs 1, 2, 3, 4, 6, 4 electrons, minus half into number of electrons as bond pairs 1, 2, 2 bonds means 4 electrons, 2 bonds means 4 electrons. Okay, so now it is 6 minus 6, that is equal to how much? 0. So the formal charge on this one is 0, oxygen. So when compared to the structure 1 and structure 2, 2 Lewis structures we are able to write. First Lewis structure +1 -1 only. Second Lewis structure also +1 and -1. So magnitude wise, both are same, +1 -1, +1 -1 only. But plus charge is present on nitrogen, here also present on nitrogen. Okay, now you see the negative charge is present on oxygen, here negative charge is present on nitrogen. That is only the difference. Okay, I have given the statement so someone can respond. So which structure you are expecting is more stable? As per the information already given to you, so which resonance structures, among the 2 resonance structures, which resonance structure you are expecting is more stable? First one or second one? So see the formal charges, both are having +1 -1, +1 -1 only, though there is no change in the difference in the magnitude. First we have to consider the magnitude. Lesser the formal charges, more is the stability. Lesser the formal charges, more is the stability. Both of them have the magnitude of the formal charges same. So next what we need to consider? Respond. What is the point I've given? Raghavan. What is the given? Negative charge is on more electronegative atom, gives more stable. Correct now?
Sir.
Tell me.
సార్ అంటే మనము ఇప్పుడు అంటే అంటే అయితే ఎక్కువ ఎలక్ట్రోనెగటివ్ ఆటం ఉందో దానిపైన చార్జ్ చూసుకోవాలి సార్.
నెగటివ్ చార్జ్ రావాలి. So you see, in this structure, the plus charges position is no difference. Only the charge difference is what? In this first structure, you have the negative charge on oxygen. In the second structure, the negative charge is on nitrogen. So the negative charge on more electronegative atom gives more stability. than less electronegative atom. So nitrogen and oxygen, among these two, oxygen is more electronegative. So on that, if negative charge is present, that is what even more stable than this one. So clearly, first resonance structure, first Lewis structure, first this resonance structure is more stable than this resonance structure. Okay, so let us take the third one. Third resonance structure also I was able to write now, I've written. So let us go to the third one. What is the third resonance structure that we can write for a N2O, N, single bond, and triple bond O, oxygen carry lone pair. Okay, no lone pairs come to here. This one contains 3 lone pairs. So number it as 1 and 2. And oxygen is only one oxygen is there, so no need to give numbering. So find the formal charge. Find the formal charge of first nitrogen. First nitrogen formal charge 5 minus number of electrons as a lone pair 6 minus half into number of electrons as bond pairs 2. Okay, so 2 ones are, so it is -1. So what is the charge you are getting? -1, -1, total charge is -2. So the first nitrogen carry -2 charge. The second nitrogen formal charge is equal to 5 minus, okay. Nitrogen carry no lone pairs 0 minus half into number of electron bond pairs 1, 2, 3, 4 bond pairs 4 2s are 8. So you will get how much? -4 5 minus 4 means it is how much? +1. Okay, formal charge of oxygen. That is 6 electrons in the free state minus number of electrons as a lone pairs 2 minus half into number of electrons as bond pairs 1, 2, 3. 3 bonds means 3 2s are 6 electrons. 3 bonds means 3 2s are 6 electrons. So that is, so it is -3, -2, -5. So it will be what? +1. So this third one, nitrogen, another oxygen contains lone pair, and this one contains 3 lone pairs like this. So now you can write the charges on them. So what is the charges coming on the first one? -2. Okay, what is the charge coming on? These are not oxidation states, please keep in mind. These are all not oxidation states, they are formal charges, okay? Not oxidation states, please. Okay, now -2 is came for this, and for this it is coming +1, and for this it is coming +1, and this one also we are getting how much? +1. -2, +1, and +1. So the total charge is 0. The total net charge is 0. So totally we are able to write 3 resonance structures. So among all the 3 resonance structures, which resonance structure is most stable? Among all resonance structures, which resonance structure is most stable?
The first one, sir.
First one is more stable. And then which one is more stable?
So third one.
Right.
Second one, sir.
Second one.
Second one is more stable. Third one contains what? -2. More is the magnitude of the formal charge. More magnitude of the formal charge results. Okay, less stability. Okay. Okay, now more negative charges are more electronegative atom than less electronegative atom. Okay, it gives more stability. So the order of stability is, order of stability is stabilities 1 greater than, 2 greater than, 3 for lesser. You can understand for lesser. 3 3 is highly unstable because positive charge are more electronegative atom. Okay, 0 is okay, but positive charge are more electronegative atom, and -2 charge, more magnitude, -2 charge is on nitrogen, is highly unfavorable. Highly unfavorable. So you can ignore this structure. That molecule doesn't want to attain that kind of structure at all. So the possibility of the third one is highly impossible. So you can have two structures relatively stable. Among the two structures, first structure is more stable than second structure. So then this characteristic, whatever the characteristic, the bond character, triple bond, single bond character is appearing in this structure, okay, will be contributed. This flavor, characteristics of flavor will be more present in the hybrid original structure of N2O. So this structure contribution will be more to the original structure of N2O. This structure contribution little less when compared to this. So this one does not at all will contribute. So its contribution is 0. A very less, so insignificant contribution. So these are all the contributory structures. This one will contribute more because this is more stable resonance structure. So the more stable resonance structure can be identified by using the formal charges. So this is the way to assign the formal charges. Okay, so all the best for the exam. Okay, we'll meet again in the next class.
Sir, formal charge లేదు కదా ఎగ్జామ్ లో.
Formal charge లేదు exam లో. Resonance formal charge is not there in the exam. It is there in the today's the schedule only.
ఓకే సార్.
So revise all the question papers once again. ఓకే, క్లోజ్ చేస్తున్నాను.